The question tells us that a fair coin is tossed into the air, and if we get a heads, we can put a white ball into our box. Otherwise, if we get a tails, we place a red ball into our box. Now we repeat this process a second time, such that if we get head, we have two white balls in our container / box. If we get head-tail, our box contains a white ball and a red ball. Tail heads is red-white, and tail is red-red. Now once we've got one of these containers, let's say for the sake of example we have a container or a box containing a white ball and a red ball, we pick a ball out with replacement at random. So let's say for the sake of example, the first ball we pick out was a red ball, and because we're doing with replacement, we place that red ball back inside the box after we have picked it out. And then we do this process a second time. In this case, we can see we picked out a white ball, and again for the third time, in such that we have picked out 3 balls in total. Before we get on to the question, let's define some notation. We'll denote the box state, i.e. what color balls are stored in the box, with the letter B, and the picked state, i.e. which color balls we have picked out of the box, with the letter P. Now the question asks us, what is the probability that the box contains 2 red balls if we know that we have picked out 3 red balls in a row? Before we try and answer this question, let's populate our probability tree with some values that we know. Since we had a fair coin, it is fair to say that all the branches should have a value of a half, which means the combined probability of each of the possible box states is 1/4. Okay, so it's hard to understand what we mean by the probability of the box state given picked. But the probability of picked given box state is a lot easier to work out and quite obvious from the question itself. So let's try and use Bayes' rule to swap our given probabilities around. So we can see the probability of the box state given the picked state is now written in terms of the probability of the picked state given the box state, which we know the value of, which I'll come to in a second. But the challenging part here is the denominator. It is not immediately obvious what we mean by the probability of the picked being red, red, red. But we can use reverse marginalization, or some people call it demarginalization, to write the probability of picked being red, red, red in terms of a series of given probabilities of all possible states that the box state could have been in. In this case, the box state has 4 different probabilities corresponding to red, 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 white, white, red, and white, white, which allows us to add 4 terms together to calculate the probability of picked being red, red, red. Now that we know these values, we can substitute into our fraction to work out the question being asked. So let's look at the numerator to make sure we're all on the same page. The probability of picked being red, 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 given the box state is red, red, must be 1, because if the box only has 2 red balls, obviously we can only pick out a red ball every single time to end up with red, red, red. The probability of B equal RR must be 1/4, as we can see from our probability tree. Similarly, we can work through all the different terms in denominator, which comes from the demarginalized version of the probability of picked being red, red, red. So plugging these numbers into our calculator or into your brain if you're a mental maths guru, we get an answer of 4/5. And yep, that's the answer we're looking for.